This episode is brought to you by Raycon. In the future, a technologically advanced humanity might find it has sucked its world dry and turned its eyes to other tempting worlds. But can there be any world more tempting than a past incarnation of our own planet? And if so, might we invade and conquer our own past? Probably one of the most common themes in science fiction is time travel, and even outside that genre it is pretty common in fiction. Folks asking what if, like what if I had done things differently, or what if this hadn't happened, or this had, isn't just a popular storyline but a habit we all engage in both after a situation, when we ruminate on alternative outcomes, and when trying to make decisions in the first place, where we seek to predict plausible outcomes. Now for my part, I'm very dubious about concepts like time travel and alternate timelines. They've been popularized because they are great for fiction rather than any strong evidence they can or do occur. However, our knowledge of time is still almost entirely theoretical, so today we will be discussing both why the possibility of time travel or alternate timelines is dubious, but also how we might use time travel or alternate timelines if we could make it work. There's also the question of how wars conducted through time might go. In the future, the order to attack at dawn might be answered by which one, sir, and fleets might be trying to achieve strategic positioning in terms of outflanking their enemy temporally. In one of Roger Zelazny's lesser-known gems, Creatures of Light and Darkness, we have martial combatants who essentially hop through time just an instant and end up making many copies of themselves simultaneously fighting their opponent and that opponent's copies, all while trying to one-up each other on foresight and prediction. One of the nominal protagonists is fathered by his own son, too, and Zelazny explores the concept in his typically excellent mind-bending and poetic style. Time travel and its implications is a favorite of sci-fi, and trying to figure out its practical uses and limits and side effects is the center of many excellent and also awful stories, and sometimes excellently awful stories. Many Doctor Who episodes come to mind, as the show ranges in quality so much over its decades of episodes and writers discussing time hopping. As it happens, when we contemplate likely uses, it is probably not just for jumping around history in a big blue police box for the nominal purpose of visiting strange new worlds or past events. Of course, what you do depends a lot on what you can do, which depends a lot on how time works. And in Doctor Who, they have often contemplated invasions across time, including the Toclafane from the 10th Doctor's tenure, who were humans from the year 100 trillion gone mad and seeking to invade modern Earth. We see something very similar in the 1987 film Gandahar, or Light Years, where an idyllic fantasy realm finds itself being invaded by machine men, and it turns out they were from a future incarnation of that world, trying to harvest their peaceful ancestors for genetic material to preserve a giant megabrain that was alive back then and fairly benevolent, but turned crazy over time from degeneration. I saw that one a couple years after it came out, when I was about 10, about the same time Terminator 2 came out, and they massively influenced my thoughts on time travel, mostly in the sense of making me love the stories but hate the seeming paradoxes of it all. Also about the same time the 1989 movie Millennium came out, where they raid the past for healthier humans, we also see time quakes as a side effect of messing around with time, and that pops up in Babylon 5 too, physical damage of a time quake from screwing with the past, not just time paradoxes. You could get stuff like that too, if for instance your time syncing wasn't perfect, and you get the Earth of a tenth of a second ago trying to merge with right now, or your hand interacting with a piece of your wrist where time was moving a bit slower or faster. Accelerated or slow time fields have some difficult practical consequences we tend to see get skipped in sci-fi, though we often see the consequence of rapid aging of a person or limb or object without it seeming to experience that time in any other way. Having to minimize consequences of time travel or show them in more classic ways is common in stories. Multiverses tend to help with that, on first glance anyway, and in the many-worlds theory context, as it is just a timeline for anyone involved that starts in one version of reality and picks up in another. The TV show Sliders, starring John Rhys Davies, also from the 1990s, explored jumping alternate timelines as its central plot, sliding between multiverses for the changed timeline of the week. Again, I'm not a big proponent of the concept of mini-worlds theory, which is essentially the notion of alternate timelines, not to be confused with multiverses in general. It's not universally accepted, and it is actually in contradiction to the Copenhagen interpretation of quantum mechanics that you know of from the Schrödinger's cat experiment. Either one is right or the other is, or neither is, not both. Alternate timelines are a subset of multiverse concepts where you come across two possible forks in a road and can go either way, so you do and get two realities. And such branching events continue on each road and further branch. Multiverses as a whole contain a lot of other options, like one in which gravitational or electromagnetic attraction between two particles is 10% lower or higher, or 10 billion times lower and higher, or where you have a fourth physical dimension or even more abstract stuff like circles with 359 degrees or entirely different fundamental particles or units. We covered those other types of multiverses in our Parallel Universes and Alternate Realities episode a couple years back, and the implications of multiverses to the Fermi Paradox in our episode Fermi Paradox Multiverse. Today we are focused on the idea that you might invade your own past history or alternate timelines. Now, there's a lot of different theories on how alternate timelines would be, so I should emphasize that whenever you hear folks beating up on sci-fi films involving time travel or alternate timelines for bad science, that does need to be taken with a grain of salt. There is no agreed upon consensus as to how time and timelines work, and paradoxes seem to occur with any version of them, even the versions where time is entirely a single linear path with no loops, branches, or redos. That said, Hollywood is not a good place to go for how they work either. A story with time travel in it is usually a metaphor for free will, destiny, and if one person can make a difference. Alternate timelines are usually about if the same person were exposed to different events or just had one key difference to themselves, those what-if scenarios. Usually it changed the amounts to one single sentence. For a high-concept story, what if someone other than Steve Rogers became Captain America and punched Adolf Hitler? Indeed, time travel stories involving World War II alone probably represent their own special category of time travel stories. Also, you've got the ones where the protagonist influenced that figure into an action that caused our current past, like convincing Caesar to cross the Rubicon, or they insert a more modern and humanist thought into a more savage warlord of history. This is one style of invading time, not with an army or even necessarily force, just one lone person armed with knowledge, and possibly superweapons too. And we also see examples of aliens or time travelers pretending to be historical figures, or not even pretending, they just were. Probably the most famous time traveler of the Marvel Comics universe, especially after the Loki TV show, is Nathaniel Richards, aka Kang the Conqueror, who was also the fictional pharaoh Rama-Tut of ancient times, but was born 1,000 years from now. Today's episode is really more about the notion that you would flat out invade your own past with armies and colonists, which is usually considered a no-no because there's no way you could avoid utterly changing the past. But that's only a problem if the notion of temporal inertia holds true, which we'll get to in a moment. Philosophically, free will either does or does not exist. If things are foreordained, then obviously you don't have multiple timelines, though you can still have other types of multiverses, and that's probably a big reason I dislike the branching timelines notion at a personal level, because to me if there's two forks at every decision, free will is what helps me pick a road. And if I'm actually going down both, there was no decision or free will. There's also no meaningful concept of identity either, as the most familiar concept we have nowadays for personal identity is John Locke's notion of psychological continuity. You are not identical to when you were born, indeed you have virtually none of your original atoms, and yet we consider that the same person, and do so on the basis of continuity of thought and purpose. A tree too changes as it grows from sapling to tree to pile of lumber at a carpenter's workshop, and we would say at that point, as it becomes a table and a desk and some wooden ladles, the tree no longer exists. Who exactly is you in some alternate timeline where Hitler won World War II? Well, a lot of people presumably, as there's so many different ways that war could have turned out differently, like one where JFK drowned when his boat was hit by a Japanese destroyer, Or just far more mundane stuff. What if your parents never met? What if they did and even got married, but you were born one day later? It is quite likely you would have the same name and general upbringing. Are you still you? Well, you've got the same DNA. You actually don't, since it's a random mix of your parents, depending on which of billions of sperm win the race. But let's say it was. You are absolutely not your DNA. Heck, the overwhelming majority of cells in your body don't even have your DNA in them. There are red blood cells with no DNA or non-human bacteria, but why would we suddenly decide that's not you? Particularly given that samples of your DNA taken randomly across your body in lifetime will not perfectly match. A cell near your stomach and another from your foot may be different, same as they might be if you took one from your 5-year-old and 50-year-old incarnations, or your alternate timeline where you decide to go for a trip to the beach and suntan or visit an area with a slightly higher background radiation level. Mutation happens. Isn't a human really more of an ecosystem with a composition and personality that slowly alters over time? Slight digression, but ever since we discovered DNA half a century ago, we have had a bad habit of equating that with your identity or implying bits of you that lacked it aren't you. This should not be treated as the fundamental definer of what a person is, or the boundary of humanity. Those personal experiences mean far more, and in a lot of theories you would almost be easier defining timelines by the person than the entire universe anyway. After all, no event that occurred here on Earth in the year 2020 could yet have impacted anybody at our closest neighbor Alpha Centauri, 4 light years away, let alone those millions of light years from here, which is the overwhelming majority of the universe. No act of any human could have impacted a galaxy beyond our own yet, unless time travel or faster-than-light travel exist, and the two are functionally identical in almost every respect anyway. To have one is to have the other. And when we say the speed of light is as fast as we can go, that's really a name that exists because we measured light before we measured the speed of gravity. They are the same, or the maximum speed cause and effect could happen at. The speed of light is really the speed of causality, and if there is a universe for every single decision, indeed for every single event, then you would have near infinite realities that were identical in every way except that billions of light years away, some minor thing happened. A uranium particle decayed today rather than a million years from now, or 1 second ago. This would have no impact on our area of the universe for billions of years, and honestly little where it happened either. Indeed, for most of the observable universe, it will never have any impact, because most of the universe we can currently see is already over the cosmological event horizon. Event horizons are not black holes, though black holes have them. They are simply the point at which the effects of any given event can never reach another place to influence them. They are over the horizon, unseen and uninvolved. So is virtually every alternate reality identical to tons of others in every detectable way, or do these just not get created if or until events reach them? Can I invade a galaxy 2 billion light years away but 1 billion years ago without causing paradoxes? Well, it should seem so. Now, because the universe is expanding, light, gravity, and causality will take more than 2 billion years to get here from that place, but ignoring that for conceptual simplicity, are the alternate realities breaking here when the event of those invasions reach us 2 billion years later? If that's the case, do different alternate realities spring up when the event reaches Mars, maybe 20 minutes later? So what if there were 2 invasions on opposite sides of the galactic supercluster, Alpha and Beta? So that Earth found out about Alpha at noon and Beta at 12:10, but Mars finds out about Alpha at 12:20 and Beta at 11:50. Did we get modified timelines for each of these scenarios? Did event Beta cause a new timeline on Mars at 11:50 and a separate one on Earth at 12:10? Did we get a new one for each other planet in the solar system, each space habitat orbiting one of them? What about each person observing the message? How about each individual atom? Do we also get a new timeline for each atom contained in the invading fleet as well? Would time travel, or faster-than-light travel, be possible so long as you always went further away than where your signal could reach you before you left? You can jump 25 light years away 24 years back in time because your ship or signal can't cover that distance home in time to cause a paradox. Could you then jump to another spot 25 light years away again and 24 years back in time 48 years ago, but sideways or actually closer to Earth so your signal doesn't need 48 years to arrive? If so, can I cause time paradoxes with any two jumps? Also, what's actually preventing you from doing these paradoxical trips anyway? Time cops? Great for stories, but not really viable, since someone could still break the rules or mess up enforcement of them. There's another thing too. I was talking about jumping between stars, like through a gateway to hyperspace, rather than just traveling the distance like by warp drive or even just classic engines. We tend to almost always treat time travel like that. Your exceptions are generally when the film or show wants to give you a montage of events that occurred during your jump, like Buck Rogers when he gets frozen, or Fry from Futurama parodying that. In those cases, the person was just frozen in a capsule or drifting. Someone could have gone and smashed their capsule up while they were on ice. What if moving through time forward or backward was just a speeding up or reversing, not jumping out of the universe and back in at a desired moment? In a fast time bubble too, where is your air to breathe coming from, or light to see by? Why are you not being blinded by a century's worth of outside light hitting your eyeballs in seconds of personal time? And outside that bubble, for a fast time bubble, why isn't the heat of a person or machine inside that bubble, experiencing centuries for every second outside, not blowing the whole area to pieces? It is functionally identical to how a chemical bomb works after all, a sudden massive generation of heat. Same concept for matter from the future suddenly arriving here and now, like a time traveler, and locally violating conservation of energy, plus asking what happens to displaced air or other matter where they arrived at. It is worth mentioning that while we don't have a great grasp of what time is, we do know it can run at different speeds in the same universe. Time moves slower when you move faster, or when you're accelerating or decelerating, or just in heavier gravitational areas. Time runs slower in your basement than your attic, indeed your head and feet, and presumably slower in all those electrons whipping around protons at a high fraction of light speed, though that's not really an accurate model of how atoms work, and time gets even weirder at the quantum scale. Time runs slower or faster at poles versus equator, or valley versus hill, on Mars than Earth or Venus. Time runs much faster on a comet in deep space than at the sun's core, and runs slower at the galactic core than in deep intergalactic space. That's not just theory, we have outright measured time flow differences ever since Einstein proposed all this and found they matched our predictions exactly, over and over again. This is time travel as we know it. The idea that time proceeds forward at a set rate for all to experience, with instant cause and effect, has been out of the window for over a century. Time runs a little faster or slower here and there, and cause and effect take time to propagate. So we can artificially slow time, very drastically near dense and massive things like neutron stars and black holes, and we can hypothesize with negative matter or energy, we might be able to speed time up instead of down, or reverse it, but you would still be sitting there experiencing it, not instantly popping from A to B, and someone could presumably see you making this journey too. You invade backward in time till today, from a month from now, and the journey takes you a few minutes of personal time, maybe while standing still, maybe while walking or marching an army, and folks see you arrive, then presumably see you break in two as one of you proceeds at normal speed again, and another of you begins walking backwards at a snail's pace to return to the time and point you left from. What would happen if you shot at that very vulnerable slow reverse marching army instead of its future self attacking you normally? A question folks often ask is where all the energy is coming from to make these alternate timelines. One common answer is to either shrug and point out the same question applies to where our universe came from back at moment zero, the Big Bang, as it is presumably no harder or easier to source it for a new timeline. Another is to say that we shouldn't assume it was actually made at that point, that there's a near infinite number of ways a universe may be arranged in terms of the locations of any given particle, and that every possible combination simply exists. There is no classic time, just a near-infinite number of static universes for each unique layout and size, and that what we think of as time is simply your journey between those universes. And that by default that journey rolls downhill from denser, more compact universes to more expanded ones, or even that your own thoughts are just one current along the vast number of combinations of atoms forming your brain. In that, your unique identity is just the path followed between all of those, same as if we took out a 2D map of the planet and drew a long path around it, presumably without intersections being allowed. In this scenario, there is no paradox with time travel. Indeed, there is no time. Someone presumably just has a path where their brain happens to be observing what would appear to be time travel events. Indeed, in an infinite universe where everything that can happen eventually does, and where quantum mechanics allows even a complete brain with memories to form at random by extreme freak coincidence, there's going to be a reality where someone springs up out of nothing with fake random memories that happen to show them having gotten into a time travel box and set coordinates for here and now. See our Infinite Improbability Issues episode for more discussion of that and quantum cheeseburgers. Key notion though, in such a setup people invade the past a lot, because there are a near infinite number of scenarios where atoms can be arranged such that they would involve a brain that thought it remembered past future events. No paradoxes implied. Another option for looking at time, which is a little more useful for time travel, is time loops. This is where a person's timeline as a time traveler might have them living a century, but they did it by being born in the year 3000, living there to the year 3025, traveling back in time to 2975, and living another 50 years, during which they see their original being born again and jumping back in time, possibly because you taught them how to do it. Then you go on to live to the year 3050, 100 years of total life spanning a 75-year window. 25 of those years overlapped, 3000 to 3025. One wonders if the universe has any issue with you suddenly removing around 100 kilograms of mass and energy from the year 3025 and adding it to the year 2975. That definitely changes events, incidentally. You could teleport yourself to a tiny little life support cubicle hidden inside a mountain and stay there not interfering. No butterfly flapping its wings. And yet your extra mass adds to Earth's gravity and slows time here just a little bit more. Even if the means of travel was actually just copying your data from collections of atoms now to another else when in the past, then that changed pattern of atoms, which presumably is taking actions, now that we've turned it from harmless rock or air into you, is still also interacting with all the gravity, light, neutrinos, and so on passing through them, and very occasionally nudging one in a different way than it otherwise would have, with its original pattern before we transmuted it into you. So yes, you're going to change time. That's a reality. Unless again you're outside its window or cone of causality. You teleported 25 years back in time but 26 light years away, but you still changed time there. You just didn't paradox your own timeline because you can't get back to Earth in time to tell yourself not to build a time machine. You could get back to a distant time and place and build a huge space fleet able to arrive in a few months to provide hope to your own future though. The paradox of traveling back in time to kill your grandfather, or sleep with your grandmother, or some other depraved activity time travelers are prone to, isn't the same as simply altering the past. It's altering it in a way that would seem to prevent the trip itself. You go back to kill Hitler and succeed, and thus time changes and nobody has a reason to kill Hitler, thus the trip is never made. Alternatively, going back in time to build an armada that cannot have its light even reach your invaders till after you left causes no paradox. If you go back in time to a gold mine before someone bought it and buy it yourself and leave the title and deed in a safe deposit box for your later discovery, it is hard to arrange that in some way that's going to result in you getting it without disrupting the chain of events that led you to pursuing that course of action. You could leave today at noon to the past and buy a gold mine and have the deed arrive by courier to your future self that afternoon, but how do you know that gold mine existed to be exploited? Maybe you put the deed in some fictitious name and transfer it to your modern self privately in the past, and that message arrives the afternoon after your time trip. that might let you get around a paradox. Alternatively, there is no paradox simply for moving through time at varying rates, and that could include backwards, much as I can lay a string across a map of Earth in a straight line as a shortest journey, or a great circle, but can also bend it for many destinations in a zigzag or even curve back on itself as you drive around an area then come home at the end of the day to the same place. We shouldn't assume a default single universe with a singular timeline has any problem with that activity, or that, if each of those map points was a single reality, that voyaging through them causes a problem. However, if we're sticking to one changeable but singular timeline, then any loops need to be closed. That point of intersection does need to be identical, which in this context means that we're talking about events that were their own cause and effect. Fiction loves to play with this, and it makes some amazing stories, often where the event the time traveler went back in time to prevent was caused by them. This is generally the view of time travel Einstein subscribed to as well, that every change you made would already have been done by you, because your future self would already have caused the sequences of events to unfold that way. Meaning if Bruce Wayne goes back in time to save his parents, he is going to end up causing the event that killed them, or more accurately, he will cause the sequence of events that causes his jump back in time. Basically the entire self-fulfilling prophecy concept. A slight variation of that is that you can invent FTL but not time travel, because no one ever used it for that even though they can. Which would seem absurd, except for if every use of time travel effectively erases the cause for it. Nobody uses time travel because it's dangerous on paper, and all the theories and reasons say it's a terrible idea, and when someone gets suicidally reckless to give it a try, they no longer have a reason to be the first to try it anymore, and thus don't try it, that day anyway, maybe another, but the same thing just keeps happening to them or anyone else. This isn't assuming any intelligent governing agency like time cops for instance, or He Who Remains. It's more the notion of the Novikov self-consistency principle, which we might phrase as saying that water in the ocean returns to the ocean eventually. It doesn't do so through volition or guidance, and it does not matter if it left with a bucket or by evaporation. It doesn't matter if it rained on a frozen mountain and sat there for 10 millennia or on a seashore, if it came by one river or another, or if it bounced around a billion points in between. Eventually, it gets back to where it started. Every time loop must close back on a point that gives the actor the exact same state of mind as when they left the first time, or the inevitable same cause of events. It wouldn't matter if time looped repeatedly there either, with 1,000 different scenarios playing out before the realignment occurred, any more than it matters if a wire loops around once or coils thousands of times. The loop will keep happening with minor changes until self-correction is achieved. Unless of course we stretch that analogy to include something like electrical resistance. After a certain number of events, the loop fizzles rather than realigns. Or maybe the reverse, and it is able to make a real change to the timeline after knocking the revolving wheel enough off axis. Temporal inertia is a common one too, favored by Isaac Asimov in his time travel novel The End of Eternity, my own favorite novel by him. Things that were meant to happen tend to happen, or they are all attractor states in history. That one also sees a sort of Cold War between the Eternals, who manipulate countless centuries through the year 1 million AD, with a future group trying to dampen out or stop their tinkering from affecting them. In the story, time has an inertia that tends to self-correct, like a rock thrown in a pond, waves on a pond settling flat over a distance, and time leaving an effectively identical pond, even if every individual molecule of water is in a different place than it otherwise would have been. So that further future group is able to basically establish a time wall around their era, starting thousands of centuries earlier, that prevents the Eternals time traveling in, and thus the inertia of time allows humanity to return to where it was supposed to be in time for them to exist. Some more spoilers, but even further ahead in time, both groups find humanity has died off circa the year 15 million AD, and they make the argument that time travel technology itself, as opposed to space travel, is a suicide pact technology for civilizations, and we explored those in our recent episode on technological time bombs and the Fermi paradox. Another favorite author of mine, Alastair Reynolds, implies in one of his books that the use of any technology for time travel or faster-than-light travel, which are inextricably linked, has a tendency to self-correct by deleting the entire offending civilization backwards in time to prevent them generating paradoxes with their FTL methods. There is some legitimacy to this concept of inertia too. Events aren't inevitable, but certain things tend to be easy to predict the general form of. The pond state is predictable even if the individual water molecules are not. I'm no psychic when I look out my window and see the clouds and say, "Ah, rain soon." And if it blows a bit north of me like it did a couple days back, well, that doesn't mean I was misreading the signs or that the thing was inevitable but somehow disrupted. There are physical reasons why it rains, and there are psychological reasons why people fight with each other or get married or start a business or family or whichever. A man is not necessarily predestined to start a restaurant, but if he loves cooking and watches cooking shows and talks about how it's his dream, well, we need not be having prophetic visions for us to guess he might be a restaurant owner someday. And that's the notion of such kinds of inertia. Not the magic of time self-correcting, but the statistical certainty that even though you can't predict whether any coin will come up heads or tails, if you flip 1,000,000 coins, you are practically guaranteed to have half heads and half tails to a tiny fraction of a percent of difference. We explored this notion more in our episode on psychohistory, and it does have some big problems. I don't think temporal inertia holds up as a valid concept. Other models are cyclic, and for instance, under the current Big Bang model, no matter what happens between the Big Bang and the end of eternity, the universe we see would have begun as a point-like object of insane heat and density and would end as a statistical washout. There may be a near infinite number of configurations a universe at heat death could be in, but they're all effectively identical, like a sea composed of nothing but water molecules. It hardly matters which ones are which and where and when. In that sort of context, a person moving from that heat death to the Big Bang shouldn't have any paradox issues because they cannot affect the outcome. You start and stop at the bottom of the hill, it doesn't matter what path you followed up and down it. Of course, that's a pretty big motivation for time travel too, to escape that heat death. As we suggested near the beginning of today's episode, when your world is near its own end, heading back to its beginning is a nice option. Now, if you have a reality that allows for those kinds of travels, so you are not eliminating your reason for existing but merely breaking off a new timeline, then one possibility you have is that you would expect more timelines the older a universe gets, and more realities. As we said back at the Big Bang, if everything is point-like, there is no meaningful arrangement of particles through space to represent an array of options. As expansion begins and space gets bigger, there's a lot more individual arrangements particles can have throughout space. Just as an example, if space is a 10 by 10 by 10 cube with one particle in it, there are 1,000 spots it could be in, 1,000 realities as it were. If there's 2 particles in that space, there's 1,000,000 realities, or 999,000 if they're not allowed to be both at the same point, and less if we have 2 identical particles and don't care if A or B are at a given spot. Get 3 particles and it jumps to 1,000,000,000 layouts. Increase that cube to 100 by 100 by 100, and now it's 1,000,000 layouts for a single particle, 1,000,000,000,000 for 2, and 1,000,000,000,000 for 3. Inside the observable universe, we estimate there would be about 10 to the 185 Planck volumes, tiny little spots of space much smaller than an atom that we think represent the effective minimum pixel of reality. Our cube or sphere would then be 10 to the 185 cells in total, and any given atom could have that many positions, and a universe of just 2 could have 10 to the 370 different unique arrangements. They are estimated to be around 10 to the 80 atoms in the observable universe. I won't bother rattling off the number of possible realities that entails, just understand that adding just one more atom brings another 10 to the 185 more in, not just one more combination. So too, every time the universe adds one more Planck length of volume by Hubble expansion, those odds leap up even more. So every second the universe ages, vastly more combinations are possible than before. This may be very slightly countered out by vast amounts of matter being removed from each other's Hubble volumes with expansion, since they can no longer affect each other at those distances, but I'm not sure that would pertain to whether or not they counted as valid combinations. If they do still count, then the very high probability the universe is infinite matters. We only discussed the observable universe incidentally. Science has no opinion or data on things beyond that, besides that they should almost certainly exist, and be more than there is in the observable region. See our episode The Edge of the Universe for details. What's this got to do with Time Wars incidentally? Well, let us assume that intelligence developing becomes more likely the longer the universe exists. In its current age anyway. After stars stop forming, this ceases to be true. However, the older a universe is, the more likely it is to have had a species develop, or even spawn randomly, Boltzmann brain style, that is able to develop time travel technology if it is possible, or for that matter, evolve the ability to engage in time travel organically. The older the universe gets, the exponentially more versions of it include some agency able to travel through time if it can do so. Thus, the more of them would exist who, by default, would be turning a predatory eye toward past epochs of the universe. There are far, far fewer of these past epochs. To emphasize scale here, if only 1 trillion future humanities was able to get the technology and desire for invading back in time, it wouldn't even need to wait 1 second before it would have more realities in which they existed with that will and ability than there were realities a second ago for them to invade. It's not that a second from now there are a trillion new possible futures for us, and 1 second more there are another trillion. It's that 1 second more and there's a trillion, each wanting to send an army back to this singular reality. And that's way, way fewer than there actually are too, by the math. I'm just too lazy to run the ridiculously huge numbers in order to obtain a wild estimate of a value whose numerical value is meaninglessly huge. So your invaders are jumping back in time and running into primitive forces they can easily beat, plus a trillion times as many other invading armies looking to do the same thing they are doing. Each of those would be spawning new alternate timelines, of course, but each one would have a near infinite number of future states where someone would have the means and ability to invade backward in time too, more so since the ability to do so is part of their history. So now you have armies invading a pristine planet who literally outnumber the stars themselves, to the point that that planet is going to undergo gravitational collapse into a black hole as they feed people into the grinder. Amusingly, this might get them what they want, since we have many theories suggesting that black holes form and generate a new universe with a Big Bang on their other side. However, proof this shouldn't work can be obtained by simply noting that we are not being invaded and squished into a black hole, but should have a near infinite number of futures who should want to do this to us, even if it seems insane, so presumably cannot. This doesn't require armies either, the same math applies just to historians coming back to visit a spot, or time travelers stuck in a loop where they just keep dropping new bodies onto an ever-deepening pile, something played with in both Doctor Who's episode Heaven Sent and Peter Hamilton's sci-fi novel The Abyss Beyond Dreams, both of which are nightmare fuel. If you've got a time loop that keeps causing a new person to fall through to some place, followed by another version of them again and again, it is beyond horrifying. But the good news is that nightmare eventually should result in a singularity forming, though that might just mean an ultra-fast, merciful death, or that the rising mass means time freezes locally eventually, but should just keep rising and rising. We don't really have a good enough understanding of space-time to know if that ends at some point with a Big Bang, though it's certainly been discussed before. Armies and fleets or just one lone historian coming through to a place of curiosity eventually should result in this occurring. If time travel is possible and practical in this way, with splitting off new timelines, you could end up with each one turning into a giant black hole, which would once more result in a time travel method that, even if possible, was worse than useless. Indeed, this might be a Fermi paradox solution itself. Planets which spawn time travel turn into black holes and eat their civilizations before they make contact with each other, either destroying them or putting them in a new universe of their own. Of course, as we mentioned, a Big Bang is one of those convenient spots in a timeline where there is no space or time, so no timelines yet. So maybe the natural result of any effort to invade a prior period of your own universe just spawns a new iteration of the universe. Not a bad way to die, I suppose, spawning a new reality. Makes for a great epitaph even if no one knows you did it. Also makes you wonder if that's who or what made our universe pop into existence. I mentioned an awful lot of books during today's episode that I definitely recommend if you want more discussion and stories of time travel, and as channel regulars know, I tend to prefer audiobooks over traditional reading as I can get other projects done while I'm at it. Of course, some of those projects can be loud or in loud places, and is why you want a nice pair of noise-reducing or isolating earbuds, and I've been using my Raycon earbuds now for over 2 years to listen to audiobooks while mowing my lawn or taking a nap, or for doing a conference call while out biking. They are a great alternative to using the speakerphone, and you can reject calls or navigate audio tracks just with their earbuds, leaving you hands-free. Another thing I love about them is they don't fall out of my ear, whether I go over a bump or sleep on my side. Raycon's everyday earbuds have optimized gel tips for the perfect in-ear fit, so they are comfortable and they will not budge or fall out. And they give you high-quality audio at half the price of other premium audio brands. That's probably why Raycon Everyday Earbuds have tens of thousands of 5-star reviews, including mine. The individual earbuds have an 8-hour playtime battery life, and they recharge in their compact carrying case for 32 hours of listening time without needing to plug into a wall. And they have a wireless charging feature for the case too that you can try out. Raycon Everyday Earbuds are also Siri and Alexa compatible, and their noise isolation feature can be turned on for total immersion, or you can go into awareness mode if you need to be able to hear the world around you while listening. They've also got 3 sound profiles: pure sound for those of us who like to listen to podcasts and audiobooks, a bass boosted mode for music with a lot of beats, and a balanced mode. And they are water resilient and tough. Mine have even survived being left in my pocket through the washing machine. They won't fall out of your ear, but if you drop one in a puddle accidentally, it's usually going to survive. They're just all-around good earbuds in terms of quality, versatility, comfort, and cost. So if you're looking for a great and affordable listening experience and want to help support our show while you're at it, just click the link in the description box or go to buyraycon.com/IsaacArthur to get 15% off your Raycon purchase. Incidentally, if you're looking for more discussion and Q&A on the matter of time travel, a couple weeks back I was on Fade to Black with my friend Jimmy Church, and the main topic for 2.5 hours of live radio was time travel, paradoxes, and various theories on methods and common questions about time travel. I'll link to that interview in the episode description. So next week we'll jump a few decades into the future to ask what humanity's first space settlement will be like, and where it will be, in orbit, on the moon, or Mars, or somewhere else. Then we'll close the month out with our live stream Q&A on Sunday, August 28th at 4 p.m. Eastern Time, where we take your questions from the chat and answer them live. Then we'll be into August to discuss living in space, some of the many challenges of doing that, and how to stay sane while you're at it. Since we don't have time travel yet, if you want to see those episodes you'll have to wait till they come out. But if you want alerts when those and other episodes come out, don't forget to subscribe to the channel and hit the notifications bell. And if you enjoyed today's episode and would like to help support future episodes, please visit our website isaacarthur.net for ways to donate, or become a show patron over at Patreon. Those and other options, like our awesome social media forums for discussing futuristic concepts, can be found in the links in the description. Until next time, thanks for watching and have a great week.